how to define a function. So we looked at 3 scenarios. I'm just going to go back to one of them. So was this a function? It was even one-to-one because I can create an inverse function as well. So that's one situation. I'm given the correspondence and I look at it and say, yes, it's a function. These are values of x, these are values of y, and this is the function. The notation is f, or f of x, or p of y, or v of t. All these are notations for functions where x or y or t represent the independent variable. And of course, this is the name of the function. It could be pressure, it could be volume, it could be simply f. Okay? Now, what if I'm given a graph? So let's say I'm given this graph. Let's say I'm given this graph. And let's say I'm given this graph. And here's another. How will I know how to identify whether those graphs represent a function or not? Awesome. Thank you. By the vertical line test, I can identify whether the graph represents a function or not, because it's the same idea. If for each x I only get one y value, then that is a function. So when I draw a vertical line, of course I'm not going to draw it here. There is no way, no reason to do that. It has to be within the domain, right? Anywhere between this point and this point, or I should say this point and this point, I can draw vertical lines. So for this particular value, I'm going to say x equals 10. I see that the graph is crossed by this line in 2 different points, which means there are 2 different y values corresponding to x equals 10. I'm going to make them up, y equals 1 and y equals 8. Therefore, is the circle a function?
Nope.
Do we agree with that?
Yes.
Okay, so not a function. Good, what about this?
Yep.
By the vertical line test,
Because no matter where you
cross it?
it only crosses it once.
Exactly. So this is indeed a function. What about this?
No.
No. By the vertical line test, this is not a function. And what about this?
Yeah.
Yes. By the vertical line test, yes. One very important concept when we talk about functions is the domain. You will always hear me talk about the domain, especially when I'm asked to graph a function. I can't start graphing a function before I find its domain. It's mandatory. So let's look at a couple of functions. Here's one. Again, I'm going to make up some numbers. First, I'm going to ask, is this a function? Yes, by the vertical line test, this is a function. Good. Now I'm going to ask you, what is its domain? The domain refers to values of x.
0 to 6.
So when I establish the domain, yes, when I establish the domain, I always look at the leftmost point, which happens to be this one, at 0, and the rightmost point, which happens to be this one at 7. Because this point does not exist, it's an open point, and because this point exists, then how would we write the domain?
Parenthesis 0, comma 7.
You're
bracket.
very powerful. I meant to write 7. Very good. Do we all agree with the domain between 0 and 7? Okay, now I would like to establish the range. It's another very important item. So what is the range?
-3, 3.
Yes. So indeed, -3 from the lowest y value to the largest y value. So how do I write it again?
Bracket. -3, 3, bracket. No, comma. I mean parenthesis.
That's it.
Comma.
Because that point does
Again,
not
yeah.
exist. Very good. Now, I can still ask a lot of things here. Okay. So the first question was about the domain. The second one was about range. Let's look at the third question now. I'm going to say find the zeros of this function. So I'm going to call it f of x. What does that mean? It's synonym to the x-intercepts. So if you're asked to find the zeros of a function, you're asked to find where the function is 0. Where the function is 0 is when
It crosses
the x-axis. Exactly. X-intercepts. Same thing. Not to confuse you, but they are used interchangeably. Sometimes you will be asked to find the zeros. Sometimes you will be asked to find the x-intercept. It's the same thing. So I always kindly ask you to present them as an ordered pair. Can anyone give us, other than Tom, the x-intercepts?
1, 0, 6, 0.
Do you all agree? So the graph crosses at this point and crosses at this point. So obviously 1, 0, 6, 0. Because the equation, no cell phones please, because the equation of the x-axis is y equals 0. That's the reason why we have those zeros in there. Perfect. Another question would be the y-intercept. So number 4. Oops. Oh, I don't need that. Okay. So is there a y-intercept?
No.
No, indeed. None. There is no y-intercept. This point does not exist. This is an open point. So there is no y-intercept. Number 5. I would like to talk about increasing, decreasing intervals. Number 6, local max, local min. There is another word that is synonym to local. Some books use the word local. Some books use the word relative. They mean the same thing. So relative max, relative min, or local max, local min. Okay. I'm going to start with 6. A local max or local min cannot be at the end point of the interval. It cannot. So this point, although you can say, but it's a kind of a maximum here in this interval, it cannot be considered a local max. First of all, there is another point higher than it. Not this one, but this one. It's higher than it. Secondly, at the end point of an interval, we cannot have local max, local min. So does this function have a local max? No. Does this function have a local min?
Yes.
Yes. The local min is exactly here. Why is that a local min?
Because it's the lowest point in the function.
And I can show an open interval around it. Here I cannot show an open interval around it to consider it a local max because the function does not exist on this side. But here I can show an open interval in which all function values are higher than this one. Everything around it is higher in value than this one. That's why this point is the local min. Can anyone give or read the local min point? Yes, Tom?
That would be negative, no, 3, -3.
Very good. Indeed. 3 for x, -3 for y. Very good. And there is no local max. No local max.
Can you
This-
explain again why there's no local max?
Yes.
There's,
So a local max exists. Let me give you an example. I think that will be better. I'm coming back to the previous graph. So let's say I have this function. Okay, so this function is increasing from this point till this point, and then it starts decreasing till this point, where it turns again and it starts increasing. Acceptable? Okay, so here this is a local max because I can show an open interval in which all these values are smaller than this height. This is a local minimum because I can show an open interval around it in which all these values are higher than this one. This could be -2 and all the other ones will be -1.9 or -1.8. So this is a local min and this is a local max, or relative min, relative max. This, however, it appears to be the smallest possible y value. But I cannot show you the open interval because
Would
the
it then
function
be
does not
absolute
exist on this
minimum?
side. Correct. I was going to say just that. I cannot show you the open interval. If I cannot show the open interval, it's not a local or relative. And this indeed, as Tom just said, this is a global, also called absolute minimum. So the end point of an interval can never be a local. Could be an absolute. Now, in this example, there is no absolute min here because there are values that are smaller than it. And there is no absolute max here because there are values larger than it. So this happens to be the local max and absolute max because I can show the open interval. And this happens to be the absolute min and the local min. Why local or relative? Because I can show the open interval where everything else is bigger. And here I can show the open interval where everything else is smaller. Better?
Yes.
Okay, perfect. Very good. So thank you for your question. So now let's come back to number 5. We already talked about it as I needed it here. These are the intervals on which the function is increasing, decreasing, increasing. When we talk about increasing or decreasing function or constant, we are talking about the trend when it happens, not from what to what. So we can say this. The temperature, the outdoor temperature increased by, we don't know what, between 2000 and 2007. That is the trend. That's the X. I look at the trend, and between 2000 and 2007, the temperature increased. Then 2007 and 2010, the temperature was constant. But I'm not asked to determine what is the value of that constant. And then I can say between 2005 and 2008, the temperature decreased. But I'm not asked from what value till what value when it comes to the trend. So coming back to our question here, number 5 for our graph, I will have to say that between this x value and this x value, which is between 0 and 3, the function did what? Decrease. I'm not asked to say from what value to what value. I'm only asked to say the trend between 0 and 3 is decreasing. What is the trend between 3 and 7 now? For x values between 3 and 7, the trend is increasing. So that's all I have to write. So I will be writing f is increasing on the interval 3, 6, not from what value to what value, but where it happened. And f is decreasing on the interval 0, 3. And notice they're all parentheses, no brackets here. Any questions for me? Any questions? I want to add something here, and then we'll look at problems from the book. And here's what I want to add. Symmetry. Symmetry. Are functions symmetric? Sometimes. Is it nice that a function is symmetric? Very nice. Very easy to graph. Much easier to graph. But I have to investigate that. There are two different types of symmetries for functions. And here they are. So a function can be even, or a function can be odd. If a function is not even and is not odd, we will say the function is not symmetric. Since I always run out of room, I'm going to move on to the next page. So let me give you an example. Here's a graph. And I will ask you whether you think that this graph is symmetric. You could say it's not a perfect graph, and I will have to agree. But if you bear with me, you will say it appears to be symmetric, okay? Okay, so obviously, if my graph were perfect, which is not the case, you would see the two green branches will overlap perfectly. They don't because I can't graph perfectly. But obviously, this graph is symmetric with respect to
The origin? Oh.
Y-axis. Yes, exactly. So symmetric, WRT with respect to the y-axis. Very good. So now I'm going to do this. I'm going to pick an x value somewhere. This is my x. And I would like you to tell me or give me the coordinates of this point. This is our function f of x. Can anyone give us, other than Tom, give us the coordinates of this point? I can't. My x value is x. I can make up and say it's 2 now. It's fixed. It's x. There is no discussion there. So what is the y coordinate?
Y.
Very good, but I want the other one. There is another notation for y.
F of x.
Thank you. I forgot to say not Tom. Okay, good. Now I'm going on the other side, and this time I pick negative x. Are these two symmetric? You can say, okay, I'll bear with you and say yes. Yeah, I chose them to be symmetric. Okay. Of course, they're not perfect. And can anyone, without looking on the other side, to the other side, can anyone give me the coordinates of this point? Negative x, comma.
Negative f of x.
Careful.
Inverse of f, right?
No, not yet.
Just regular old f of x.
I can't. If the x is negative x, I cannot make up whatever I want here. It has to be clear. What is it?
F of negative x.
Thank you. Right? I can't. That's why I covered it, so there is no influence.
But it's the same y coordinate.
I'm getting to that. You're way ahead of me. Awesome. Okay, so now, because the graph is symmetric with respect to the y-axis, can anyone give us, other than Tom, can anyone give us a relationship between these two values? Say it again. Yes. They are the same coordinates, right? Yes, y coordinates. So f of negative x must equal f of x. This is the relationship for an even function. F of negative x must equal f of x if the function is even and the graph, in other words, is symmetric with respect to the y-axis. Very good. Is that clear? Yes? Okay. So now let's look at the other option. I'm going to graph a different function now, of course. Here it is. Here's the graph. This is our f of x now. And I'm going to say this, that if I connect this point with a line segment going through the origin to this point, I'm going to connect it. This piece, this segment from this point to the origin is identical in length with this segment from the origin to this point. And I can continue with the other points that I created. And this time I'm going to do the same thing. So then now this piece between this and the origin and between the origin and this piece will be the same. So obviously this is another type of function that is symmetric, right? What type of symmetry is this? Obviously it's not with respect to the y-axis or with respect to the x-axis, but with respect to, what do you think? So the graph is symmetric with respect to the, thank you. And this is characteristic for an odd function. Only functions that are symmetric with respect to the origin are odd, considered odd functions. Okay. Again, I'm coming back with same idea like before. I'm going to say this is my x. I'm going to say this is my negative x. And I want to determine the coordinates of this point. Do not look at the other one just yet. So please give me, other than Tom, the coordinates of this point. You're not punished. I just wanted to,
I know.
because I know you know.
Well, I have a few ideas, but
Can anyone give us the coordinates of this point? Look back at the previous function. Comma. That's it. Perfect. Now I'm on the other side. And I want to determine the coordinates of this point.
Negative x, f of negative x.
Perfect. And like before, if you remember here, I asked you, can you give me the relationship between these two? And it was obvious they were equal. There was no discussion there. I'm going to ask you the same question here. Can you please come up with an idea of a relationship between these two numbers? So this one is here as f of negative
same
x.
absolute value.
And correct. But this is not what I'm looking for, but you're correct. So I would like a relationship between this and this. Obviously, they cannot be equal.
negative
Right.
f of x.
Wonderful. F of negative x equals negative f of x. Obviously, they are opposites of each other. If this is 5, this will be negative 5. So f of negative x is the opposite of f of x. And this is a relationship for an odd function. If a function fulfills this condition, it's odd. Its graph will be symmetric like this one with respect to the origin. So f of negative x equals the opposite f of x. Not too difficult, I would say. Bear with me here. F of negative x has to be determined in both cases. When it's even, it's the same number or function. And when it's not even, when it's odd, it's the opposite of that. So let me give you a couple of examples now. And I'm not going to graph the function, right? So let's take a look at f of x being negative x to the fourth plus 2x squared and minus 7. The question for this problem is this f of x symmetric? Of course, it's graph. And I have no idea. But I definitely have to start somewhere. And where would be my starting point? For sure.
Intercept.
Nope, we're not graphing. So where will be my starting point? I'm trying to see whether it's even or odd. By the way, is there a function that is both odd and even? Both symmetric with respect to the origin and symmetric with respect to the y-axis? The answer is yes, but it's a function that makes no sense. It's this one, which is the x-axis. Nobody cares about this function. It's the only one that is symmetric with respect to the y-axis and symmetric with respect to the origin. There is no other function that is symmetric with respect to both origin and the y-axis. Good. So then what do I have to calculate when I try to establish whether a function is symmetric or not?
Set the whole thing equal to 0.
Nope. Okay, let's go. Yes, please.
I mean, if it was even, that would equal f of negative x.
So what do I have to determine?
This-
What do we have to determine? What do we have to calculate? Look at this relationship. Look at this relationship. And in both cases, something is identical. What is it? What do I see here as well as here?
F of x.
No.
F of negative x.
Yes, you're right also. F of x, but I can't do anything to f of x.
Right.
That's what I meant to say. Yes. So this is my starting point. I have to calculate this. And then I'll say, is it f of x? Is it negative f of x? Or none of the above? Very good. That's the starting point. So for this function, can anyone dictate how to find f of negative x? What do I have to write? I have to copy negative. In parentheses, I have to put, remember how to read a function, right?
Negative x.
Yes, negative x to the fourth plus 2
Negative x squared.
in parentheses squared and minus 7. So this is the way we determine f of negative x. Acceptable, everyone? Yes, we see this? Okay, perfect. So now I have to perform some operations. Negative x to the fourth power is first. What happens to negative x when I raise it to the fourth power?
It becomes positive.
X to the fourth. With a minus in front,
Negative.
negative x to the fourth. Good. Negative x squared.
Again, same deal. With an even power, the
Awesome.
sign goes away.
So plus 2x squared and minus 7. At this point in time, I'm asking myself 3 questions. I don't have enough room, so I'm going to the next page, of course. So here are my questions. Does this equal f of x? If I say yes, I will conclude the function is even. Does this equal what?
Negative f of x.
Awesome. If the answer is yes, what will I conclude about the function?
Odd.
Good. or none of the above.
It's not symmetric.
Exactly. So the answer is yes to only one of these three. Only one. So now I compare. So this is f of negative x, and I'm comparing it now to f of x. Are they the same? Yes? The function is even, which means its graph will be symmetric with respect to
The y-axis.
the y-axis. What if I would have, what if I, in this case, I say, no, it's not even? What do I have to calculate now in order to determine whether it's odd? Negative f of x, and compare it to f of negative x. Is this clear? Yes.
Can you show me how you find like negative f of x?
Yes. For negative f of x, negative, positive, negative, positive.
Okay, I see what's
Negative
the
f of x will be x to the fourth minus 2x squared plus 7.
got it.
That will be this piece,
Whereas f of negative x is just changing the value of x.
replacing everywhere x by negative x.
Okay.
Yes. When I look at this function, because I think you were not here when we discussed this, this is what I see.
Okay.
So this function says f of whatever is negative, whatever to the fourth, plus 2, whatever squared, minus 7. So I can have whatever you want in here. I can have x plus h, which we will shortly. Okay, so it only means that I replace the variable with whatever I need to. Very good. Okay, so I would like to go through a couple of examples from your book. I'm on page 250 and page 251. Any questions?
Is this called something like something specific?
Yes, symmetry.
Just symmetry?
Yes. This is the name of a property of functions. They may have this property or not. It's nice when they do. And you'll see in chapter 3 what happens when they do. It's really nice and much easier to graph. Okay, so moving on to an example, I would like to look at problem 52 on page 251. I'm copying the graph. We have a lot of questions here to answer. So I see 1, 2, 1, 1, 2, crosses here, and it crosses here. So this is our f of x. By the way, is it a function? I already said it's f of x. Is it a function? By the vertical line test, it's a function. Very good. Perfect. So we have a lot of questions. Question number 1, domain. From
negative infinity to 6.
exactly. Do you all agree with negative infinity 6? From the leftmost x value possible till the rightmost x value possible.
Wait, can you do that again?
From the leftmost x value till the rightmost x value. Better? Very good. Number 2, range. Stop me anytime if you have questions, please. Range.
Negative infinity to 1.
Exactly. Very good. Negative infinity to 1. Yes? From the lowest y value till the largest y value. Yes? Everyone? Yes? Okay. The zeros, of course. 3. Zeros. Can anyone, other than Tom, Identify the zeros. You need some paper to write on?
All right now.
Okay,
-3, 0,
very good.
3, 0.
Very good, awesome. Do we agree with this? We see those?
Yep.
This point, the x-intercept, and this point, the x-intercept, correct? Yes? Okay, next question, number 4, is f of 0. Can anyone identify or tell us what does that mean?
F0. That means you plug in 0 at every x value.
Okay, so
So
what,
say you have f of x equals x squared. Well then f0 equals 0.
what the f does f of 0 mean?
When x is 0, what is y?
What is its name? Awesome.
Undefined.
One.
Yes, it is 1. Very good. But what does this represent? The y-intercept. Very good. You read from here. Awesome. Question number 5. Intervals on which f is increasing. F is increasing on, remember, not from what value to what value, but where is the trend?
From negative infinity to 1.
From negative infinity till
-2.
-2. Right here. So from x being negative infinity till -2, the function is increasing. Very good. We all see that? Perfect. Next. So you can see, where was I? 6. Yes. Intervals on which the function is decreasing.
From 2 to 6.
Very good. So the function is decreasing for x values between 2 and 6. Acceptable? Okay. Next, 7. F constant on very good. Very good. 8. Values of x for which f of x is strictly greater than 0. What does that mean? When f of x is strictly greater than 0, it means when the graph is where? Above the x-axis. Yes. Find the x values for which the graph is above the x-axis, meaning f of x or y are all positive.
3 to 3.
Do you all agree with -3, 3? Yes? Okay. Find values of x, so that's my number 9. Find values of x for which f of x equals -2. What am I asked to find and what am I given?
The y value when they
Yes, I am given y equals -2 and I'm asked to find x. Perfect. So now when I'm given y equals -2, I should draw a line. What type of line will I have to draw? Awesome, thank you. So it's this line. This is y equals -2. Does this line cross the graph? Yes, in how many points? Quickly, before Tom says something. Very good. We are gonna, that's the race now. We have a race against your speed. Okay, so now I will have to read the x value, which will not be possible from my graph. We have to look in the book. Okay, so there are two possibilities. F of x equals -2, and there are two values.
4 and -4.
My graph is not perfect, so it's -5 from the graph and +5. So x equals -5 and x equals 5. I'm going to make a note here. The 5 is okay. I guess this one is fine too. Good. No note is necessary. Next question, number 10. is f of 4 positive or negative? I don't know. Have to look and find f of 4. How do I find f of 4? What is given in this? X is given, right?
X is 4.
Good. How do I graph a line that represents x equals 4? Vertical, awesome. So I draw a vertical line at x equals 4. It crosses the graph in one point,
-1.
and I want to read the y value for that point. So f of 4 equals -1. So what do you conclude? Is f of 4 positive or is f of 4 negative? So f of 4 is negative. See how many questions we can, or how much information is hidden in just a little graph. Okay, 11. Is this function even, odd, or none of the above? Symmetric?
No, it's not symmetric at all.
I agree, because it continues here forever and here it ends.
Yep, stop.
It would have been if both sides would have been the same,
If you
if-
made it just a little bit longer and put the arrow on the end,
or if I had stopped here.
yeah.
Yes, so it's not symmetric. Is that clear?
Yep.
Not. Good. Last question here. Is f of 2 a relative max? 12. F of 2, relative. The book uses relative, local, whatever you want to use, it's fine. Max.
No.
So f of 2 is this point right here. Can I show the open interval in such a way that everything, all points are smaller than it, so that one is alone on the max?
No.
No.
One to the left or right.
So I will say no. However, this is just a for your information. The calculus book will always consider that. In calculus we consider that a relative max.
Well,
Because we assume that both sides or one of the two can be equal. Your book says no. I agree with the calculus, but since this is what the book says, I want to keep it. Any questions? Any questions for me? Any questions here? Okay, I would like to graph a piecewise defined function. Can anyone give us an example of a piecewise defined function? Why would we even